Okay, so we're going to be learning about logarithmic function this week, and the common logarithm has the base 10, and the natural logarithm, which is most common, uses the base e. Okay, so log 10 of x is defined as log 10 of x is equal to b, if and only if 10 to the b power is equal to x. When it comes to natural log, we have ln x, okay, which says the natural log of x is equal to b if and only if e to the b power is equal to x. Okay, so the difference between the two is just the base that they're using. The most common base for logarithm again is e, which is 2.718. Okay, so natural logarithm functions and the natural exponential functions are actually inverse functions of each other. So if they show you it right here. So their graphs are reflections of each other in the line of y equal x. So if we were to graph y equals x, which is a linear function, right? The slope would be 1, right? And the y-intercept is 0. So we have this line, and then if we had the exponential functions like we drew last time, well, the logarithmic function is just a reflection over that line. Okay? And since they're inverses of each other, we can rewrite them in each other's forms. So as we move on to this next part, we have natural log of 1 is equal to 0. So I have written here x is equal to 1, because this is the form. Okay, so x is 1 and b is 0. So if I were to rewrite it in exponential form, I put the x, I just plug in where they go. So it would be e to the 0 power, which is 1. Okay, anything to the power of 0 is 1. Okay, so you would just establish what is x, what is b, and then you rewrite it. So we have x is e, b is 1, so now I have e to the first power is equal to e. Okay, they're just proving each other that they're reflections of each other and that they're inverses. We have natural log of 1 divided by e is equal to -1. That can be written in exponential form as e to the negative first power is equal to 1 over e. Natural log of 2 is estimated to be 0.693, and if we rewrite that, the exponential form, right, e to the 0.693 is approximately 2. Okay, so let's go ahead, and what we're going to do is going to sketch the graph of the natural log of x plus 2. So you're given these values. All you have to do is plug it in, and you're going to get some values, and then you're going to just sketch the graph. So you're given the values, you plug it in. So for negative 1.5, I get negative 0.693. At negative 1, I get 0. At negative half, I get 0.405. At 0, as my x, I get 0.916. At half, scratch that. This one's 0.916. This would be 0.693. Sorry. And at 1, you get 1.099. So now I have my x and my y values, and I just sketch a graph. So at negative half, negative 1.5, I go down to negative 0.693. So right about here. Okay, negative 1 is 0. Negative half is 4.05, so just below the half. 0 is 6.93, so right about here. And then 0.5, we're at almost a 1. And then at 1, we're just above 1. So we have it going this way. Okay, and it would keep curving down and curving up that way. Okay, that's all you have to do for your sketch. Well, let's move on to the next piece. So we're talking about inverse properties of logarithms. So the inverse properties, which these are given to you like rules. So we have the natural log of e to the x is x. Okay, and the natural log, e to the natural log of x is just x. Okay, and they want us to simplify. So basically, what the power is for this one is your answer. And again, what your x is going to be your answer. Okay, so let's see. So in this form, natural log of e to the third power. my 3 is my x, so this one is just going to be equal to 3. Okay, the next one we have e to the natural log of x plus 1. Well, this whole x plus 1 is in for my x value, in like the formula. So x plus 1 would be this answer. Okay? Next, we move into the properties of logarithms. So if we have the natural log of an x and times a y, we're going to split it up by saying the natural log of x plus the natural log of y. If we have the natural log of x divided by y, then we're going to have the natural log of x minus the natural log of y. If we have the natural log of x to the n power, we would move the n in front of our natural log and keep it to the x. Okay? So let's work so you can actually understand what I'm talking about in number 3. Okay? So we have the natural log of 10 divided by 9. Using the properties, okay, I'm going to separate these into natural log of 10, because that's in the x place, minus the natural log of 9, which is in the y's place. They just want us to rewrite these expressions, okay? So there, we're done. This next one, we have natural log of the square root of x squared plus 1, okay? So I can rewrite this one, first of all, as the natural log of x squared plus 1 to the half power, since it's a square root. Okay, then I would use the property, this property right here, okay? Put the half in front, and then it's natural log of x plus 1. X squared plus 1, okay? The next one, we have natural log of x times y divided by 5. So there's 2 properties involved in this one. So the first one we would have is the division one. So we have natural log of xy, right? That's up top, which would be our whole x, minus the natural log of y, which would be natural log of 5. Right? And then I have a multiplication one right here, so I can separate these two. So when it's a multiplication one, we separate it like this. So I have ln x plus ln y, so natural log of x plus the natural log of y, minus the natural log of 5. Okay? The next one, these brackets are just like if you had a set of parentheses there. So we have natural log of x squared times x plus 1. So we are timesing them, so I can separate these into natural log of x squared plus the natural log of x plus 1. Okay? Then I have this property. So I have the power of 2, so I'm going to move it in front. So I have 2 ln, natural log, of x plus the natural log of x plus 1. Parentheses. Okay, we're just rewriting this according to the properties. The next one, I have 4 natural log of x plus 3 natural log of y. So they already have it separated. Now I'm going to rewrite it as, so they're giving us this part, so now we have to rewrite it like this. So I know if 4 is in the front, that must mean it was a power, right? So I can know that it's natural log of x to the 4th plus the natural log of y to the 3rd. Then I know if they were being plused, right? If they were being added, that comes to the property of the multiplication. So it would be the natural log of x to the 4th and y to the 3rd. Okay. Next one, I have natural log of x plus 1 minus 2 natural log of x plus 3. So I can rewrite this one when I move the 2 as the power. So I have natural log of x plus 1 minus natural log of x plus 3 squared. Okay? And I know if they're being subtracted, it must have come from a division. So I have ln of x plus 1 divided by the natural log of x plus 3 squared. Let me move that up so you can see that. Okay? Now we're going to be looking into solving each equation. So we are given e to the x to the 5th is equal to 5. So I'm going to rewrite this. So I would take the natural log of e to the x and the natural log of 5. Okay? We know that from our properties, the natural log of e to the x was x. So x is going to be equal to the natural log of 5. Okay? This next one, I want to get e by itself, so I'm going to subtract 10. So I get e to the 0.1 t power is equal to 4. Okay, we're going to take the natural log of both sides, natural log of okay? I don't just have e to the x. I'm given a value in front of this. So what I want to do is get rid of this 0.1 power. Okay? And the way we do that, well, before that, well, I know the natural log of this is going to be the x value. So my x in this case is 0.1 t equal to the natural log of 4. I need to get t by itself. Okay, so what we do to that, okay, the easiest way for me is going to be to multiply by 10. I want to get this to be 1. So what makes this 1? Well, 0.1 times 10 is going to be 1. So I have t is equal to 10 times the natural log of 4 as my expression. The next one, I have natural log of x is equal to 5. So this one, I rewrite this one as e to ln x. And then this one has e to the 5th, rewriting in exponential form. Well, I know the exponential, when it comes to the power of ln x, this was just x if we go back to the properties. Okay? So x is just equal to e to the 5th. Okay? The next one, I want to get ln x all by itself, so I'm going to subtract the 3. So I have 2 ln x is equal to 4. Okay, I'm going to divide by 2. I don't know why I wrote in there. Okay, divide by 2. Then I have ln x, natural log of x is equal to 2. So now if I rewrite this in exponential form at e to the ln x power, e to the 2nd, I know that x is e to the 2nd. Okay, just like that.